Hello students, and welcome to our next video here on calculus. We're looking at some applications now of the graph of the exponential function. Okay. So we're just going to jump into two examples for the video. First up, we're asked to differentiate this function and then find where it's stationary. So differentiating this exponential function here, right? The derivative of e to the x is e to the x. And the derivative of negative x is negative 1. So the derivative of that function is e to the x minus 1. Nice and easy. And when is that stationary? Well, that's when the derivative is equal to 0, when a tangent to that curve would be horizontal. So we let the derivative be equal to 0. That means e to the x minus 1 equals 0, or e to the x equals 1. Now, e being about 2.7 to the power of what equals 1? We could solve it with a log, but e to the power of 0 equals 1. Anything to the power of 0 equals 1. So x equals 0. That's where that stationary point is. The second example is a bit more complicated. It's quite a lot more complicated. So I've got a curve, y equals 2e to the power of x. That's an exponential. And there's a point A on that curve, which occurs when x equals 1. We don't know what y is, but we could find it. First of all, we're asked to find the equation of a tangent to that curve at that point A. So this is what the curve looks like. Something a little bit like this anyway. There's my exponential. And if x were equal to 0, then e to the 0 would be 1, and y would be 2 times 1 equals 2. So you can see that y-intercept there. The point A is going to occur when x equals 1, so it's going to be up here somewhere. Point A will be up here. I should probably have put a dot there and labelled it, but well, it's a bit late now. We want to find a tangent there and the equation of that tangent. To find the equation of a straight line, there's really typically two things I want. I want to find the gradient, and I want to find a point. Then I can use the point gradient formula. I've got half of the point so far. I've got the x-coordinate. I need to find the y-coordinate. Then I need to find the gradient. We're going to find that y-coordinate by substituting into the function. Right, so I let x equal 1 and substitute into this. So y is 2e to the 1 equals 2e, which is about 5.4. That's about right here. Right, that'll be just above my 1 there. 5.4-ish. That's where a is. So x1 equals 1, y1 equals 2e. Now I want the gradient. To find the gradient, I'm going to differentiate the function and substitute x in. So the derivative of 2e to the x is 2e to the x. Okay, nice and easy. Now I substitute x equals 1 into that. So remember, I substitute the x-coordinate into the function to find the y-coordinate, and into the derivative to find the gradient. In this case, the function and its derivative are the same. So the gradient is 2e. Now my point gradient formula, y minus y1 equals m into x minus x1. So that's x1 and y1, and that's m. So y minus y1 equals m into x minus x1. If I expand that out and tidy up a bit, I just get this equation here, y equals 2ex. Nice and easy. Right, that's part A. Part B says show that the tangent passes through the origin. Well, looking at that equation, we sort of see that it doesn't have a constant. It's in gradient intercept form, y equals mx plus b. And there isn't a b, or b equals 0. That's probably enough, but we'll do it here by substitution. There's my tangent. And you can see it's passing through the origin there. That's where x equals 0 and y equals 0. But that's not sufficient to show that it passes through the origin. We'll need to do it algebraically. There's my function. If I let x equals 0, I'm going to find the y-intercept. So at x equals 0, what does y equal? 2e times 0 is equals 0. So when x equals 0, y equals 0, that means it passes through the origin. Next up, find the equation of the normal at point A. Remember, the normal is a straight line, but it's perpendicular to the tangent. Okay, and a perpendicular gradient is the negative reciprocal of the gradient of the tangent. Right, it's going to have the same point. Again, to find the equation of that straight line, I want a point and the gradient. I've already got the point. That was 1, 2e. We found that before. And I need to find the gradient. Okay, so this is what the normal looks like. It's going to be at the point 1, 2e. The gradient of the tangent was 2e, so that means the gradient of the normal is negative 1 over 2e. Right. Now, y minus y1 equals m into x minus x1. If I rearrange that a bit, tidied up, I get y equals negative x over 2e plus 1 over 2e plus 2e. Right here. That's the equation of the normal in gradient-intercept form. This is the gradient, negative 1 over 2e, and the y-intercept is 1 over 2e plus 2e. Now, to find the point B, where that normal crosses the x-axis, so this was point A here, B is going to be here, the x-axis. To find the x-intercept, we let y equal 0. So, my function was y equals this, so now I'm going to let that equal 0. Now I'm going to add the x over 2e to both sides, gives me this equation. I'm going to multiply both sides by 2e, so x over 2e times 2e is just x. 1 over 2e times 2e is 1, and 2e times 2e is 4e squared. So x equals 1 plus 4e squared. If you evaluate that using your calculator, 4e squared plus 1, or 1 plus 4e squared, is about 30.5, and we can see there on our graph. That's about where my x-intercept is. So that's done. Find the point B where it crosses the x-axis. It is at 1 plus 4e squared, 0. That's the coordinates of B. Probably should have written that a bit more explicitly there to answer the question directly. Now find the area of AOB. Now O we can take by convention to refer to the origin. We found A, the coordinates of A, we found the coordinates of B. Here's a little sketch, and you can see in yellow there, that's the triangle we want to find the area of. Now this line OA and the line BA, right, these two blue lines might be at right angles to each other because I've got a tangent and a normal, but I don't know their lengths, and so that's not looking like a very positive way to go about finding the area of that triangle. Because I've got the coordinates of these points, I can really easily work out the length of the base here and the perpendicular height here, right? And the area, half the base times the perpendicular height. So the base is 4e squared plus 1. The perpendicular height is 2e, so half times the base times the height is 4e cubed plus e, square units if you like. Righto, that was it. Some applications. We've done a lot of those things before. We're just doing them with exponential functions this time. After this, we're moving into logarithmic functions with a base of e, and that's important that we look at those because logarithms are in many ways the inverse of exponentials. Okay, that's it for today. If you've got any questions, make sure that you write them down so you don't forget and ask me in class. See you then.